Hi, I'm back in the power shed, and it's been raining most of the day. It's cloudy, and my 6-gallon water heater is already turned off. It's 1:30 right now, and you can see I put 330 watts in it. And I took a shower last night, and you know, that's all it takes. You know, even on cloudy days, you can you know, scarf up enough power to heat some water. My other tank is at 53 degrees centigrade. That's a 10-gallon tank, so that takes longer for it to warm up. And this is the 10-gallon tank. You know, I'm putting 109 watts in it. Doesn't sound like much, but it all adds up. I've put, you know, 711 watts in it. And, you know, it's a miserable day outside. It's rainy, and so I want to talk today about PSEUDO MPPT. You know, I'm all about using these, you know, boards to create the heater voltage at power point. But I got talking with someone the other day about, they believe, and a lot of people hold on to these ideas that, you know, there's, you know, you get all the heating at 2 hours in the middle of the day, and the rest of the time really doesn't matter. Well, it's true. The rest of the time, it takes the whole rest of the day to equal what you get in those 2 hours. But some kind of MPPT is important to you, and it's amazing that you can do it with just a little simple improvement. If you look in my description, I have a table there showing what power you would get out of a 10 amp 660 volt panel. And just think of the 10 amp as 100%, and you know, 2 amps would be 20% of your total panel power. So this guy had an Arduino, and all he did was turn the resistor on and off. You know, so it was just a temperature control. You know, something you could do with a $2.50 temperature controller shipped from China. But a lot of these elements, if you look at a lot of DC elements, they're actually 2 elements in parallel. You'll see these 2 shorting bars. And if you have that, well, you have the option of, you know, taking either just 1 resistor or 2 resistors in parallel. And if you take the 2 resistors in parallel, we'll call that resistance 1. So that's 1R. And if you don't connect these both up in parallel, and you turn them on with switches, you know, these could be your solid state relays. If you turn just 1 on, then your resistance is 2R. And if you know, had enough money and you wanted to even get more power out, you could make it 3R. So you either have 1 resistor, 2 resistors in parallel, or 2 resistors in series. So you go 1R, 2R, or 4R. And 4R would only be S3 on. And you'll look in the table, and I've done the calculations for you know, 2 resistors in parallel, or just using 1 resistor. And you know, it's a marked improvement, and it happens at about 70% of maximum power panel current. And that's kind of high. That's quite, you know, if you buy a 10 amp panel and you're getting 7 amps out of it, you're thinking you're doing pretty good. But actually, if it just drops a little bit below that, you know, you start to lose a lot of power. So it's important to not have a fixed resistance, be able to change it. So this gives you, you know, 1 resistor or 2 resistors in series, and just that minor change can gather you quite a bit extra power. And if you are familiar with electrodactylus, you know, Dacian talks about this, and he has, you know, multiple combinations of resistors. which isn't really possible in a lot of circumstances. But you know, these dual heating elements, you can do it. So I hope you look at those numbers, and if you have even a little bit of coding experience, you can take one of these nanos and you know, do 2 solid-state relays. Everything's pretty much off the shelf, and you can greatly improve the power output over just a direct connect at your theoretical ideal resistance. So that's what I wanted to explain today. Thanks for watching.